Well, good evening, everybody. Apologies again that I'm not there. I promise that I'll be doing my best to be in class for the next few weeks, much more than I have been this last week. You will notice that at 6:58 p.m. on a Sunday night, look, I'm going to just have to get through this quick because, what can I say, Australian Spartan is on, and we all know what that means. Mathematics is like the journey of a Spartan team. So let's see if we can continue on that journey and see how we go. Now, you should have started some work on equations you've seen in the past. I will say that this next little bit with algebraic fractions, I was at a HSC review day and they were saying that even Extension 2 students are often showing how they aren't able to manipulate and work with fractions. So this is really something that you need to ensure that you work hard on and get a good grasp of. So let's see how we go. I'm going to do 5 examples. Now, a general thing about equations with algebraic fractions is you've got to multiply the denominators so that you get rid of them so you can solve what's left. That's your goal. And for any equations, you have to always perform operations on both sides. All right? Now, if you have more than one fraction on one side, well, my advice would be to either, combine them into one and then multiply by the denominator, or carefully do it one at a time. But let's see how we go and see what happens. All right, first one, 3x over 4 equals 6. 3x on 4 equals 6. Well, we've got a denominator of 4 over here. Denominator of 4. And so, well, we've got to sort of think about that. And obviously to get rid of it, or to, if you like, multiply that out, we have to multiply both sides by 4. Now, often the confusion is you got to multiply. People say, you got to multiply top and bottom by 4. Well, no. That's only if you want to change the form of the fraction. For instance, I'll give you an example. 3x on 4. If I multiply top and bottom by 4, that's equal to 12x over 16. All right? Now, that means that 3x on 4 and 12x on 16 actually have the same value. But this is, if you like, a changing of the form to be able to then simplify an expression. To simplify an expression. If I want to solve an equation, I don't really need to do that. I'm simply trying to solve what the value of x is for this thing. So all I need to do is, if I keep doing the same operation to both sides, then equality is maintained. So to multiply out a denominator, you just have to multiply by that same number. So I'm going to multiply this side by 4. I don't necessarily think you need to write this underneath each time. Actually, that's a bit confusing. Let me get rid of all that. So you're multiplying this whole thing by 4. Multiplying this whole thing by 4. So 4, and well, you were left with the numerator, which is 3x. 6 times 4, of course, is 24. Then we're going to divide by 3, and so 3 times what is 24? Well, x equals 8. And so in this case, we're saying, what's the value of x that will solve this? 3x on 4 equals 6. There's only one. The value is x equals 8. All right, let's have a look at the next one. Here we've got this kind of loose minus 2 here, so I'm just going to add that to both sides. So we're going to end up with t on 5 is equal to 6. Right, again, straightforward. Something, the t, something divided by 5 is equal to 6. All right, well, what is that? Well, that's 5 times 6. So I'm going to multiply both sides by 5. So t is equal to 30. All right. Now, at this point, I'll just put a note, because some of you might still be thinking, what is going on? Remember, if I have a fraction, half by 2, I multiply that with the numerator. This becomes 1 times 2 over 2. 2 over 2, which is equal to 1. Now, if we look at my original and what I end up with, well, it's just the numerator. So if I multiply a fraction by its denominator, I'm just left with the numerator. That's what I'm doing in these questions. Multiplying by 5, I get rid of the denominator, and I'm just left with the t. Right? Same principle. So just a note, that's what's happening when we do that. All right, moving right along. Number 3. Here we have a case that I mentioned before. We've got 3x on 5 minus x over 2. We've got a denominator or 5, and then we've got a denominator of 2. Now, you can do this a couple of different ways. I'm going to do it the way where I'm going to combine the 2 into 1, simplify, and then multiply. All right, so what's my common denominator? We've got a 5, we've got a 2. Well, 5 times 2, lowest common multiple in this case is 10. So here I'm going to multiply top and bottom by 2, so I get 6x on 10 minus, it's going to be 5x on 10 equals 2. Now, I haven't multiplied anything out. That's why the right-hand side is still 2. Because I've just simply, each fraction, I've just changed the way it's written. I haven't adjusted the value or multiplied or anything. I've just simply changed the way it's written. But the 6x on 10 is exactly the same as 3x on 5, just with different numbers, but the ratio is still the same. Combine these two, 6x minus 5x, that's going to be x on 10 is equal to 2. And multiply by 10 on both sides, we get x is equal to 20. And there we have it. All right, I'd suggest you, as you get more familiar with this, you might see that, if I multiply by 10 straight away, that becomes 20, and then that becomes 15x minus 5x, etc. You could do that. I mean, I'll show you that method. Method 2. So you multiply both sides by 10, because 10 is the lowest common multiple, so it's going to become 6x minus 5x is equal to 20. And so that means x equals 20. But you kind of need to know what you're doing here. And I'm not saying that many of you don't know what you're doing. You get to the same answer. But what I'm doing in method 2 is kind of method 1 with an understanding of method 1 built into it. All right? So you've got to make sure that you take those things on board and do that. All right, 2 more examples. Same idea here, we've just got a binomial in the numerator. All right, let's combine the fractions. So 4 and 3, 4 and 3. Lowest common multiple is 12. So this one is going to become 3 over y, 3 brackets, sorry, y minus 2 on 12, plus 4y on 12 equals 2. Now, I'm going to expand this bracket. It's going to become 3y minus 6 plus 4y on 12 is equal to 2. Now that I have a single denominator, I feel like I'm in a position where I can multiply it. So this numerator here that I've just put into brackets, if I simplify that, that becomes 7y minus 6. I'm going to multiply both sides by 12. That's equal to 24. Add 6. 7y is equal to 30. Divide by 7. Y is equal to 30 over 7, or that is 4 and 2/7. But hey, improper fractions, I think, are the way to go. All right, so you've got to take care, make the denominators the same, combine them together, then multiply both sides by the denominator. That goes away. 2 times 12 is 24. Then you're just solving a linear equation. All right, final example. Here we have something different again with x's and x plus 2 in the denominator. But you could say, it's different again. But actually, it's just kind of, we just treat it exactly the same way. So I'm going to make the denominator the same. So what's the common denominator? It's going to be x bracket x plus 2. So here, the first one, I've got an x. I'm going to multiply top and bottom by x plus 2. 2 x plus 2 over x plus 2 plus the second fraction. I've got x plus 2, so I need to multiply top and bottom by x. So it's going to become 3x over x plus 2. Now, that's just changed the way I've written it. It doesn't change the equation. I haven't multiplied both sides by anything, so the right-hand side is still 3. Combine the fractions, so it's going to be 2x plus 4 plus 3x over x squared. I'm going to expand it in this case. X squared plus 2x equals 3. Now the denominator is this, x squared plus 2x. So I'm going to multiply both sides by that. What happens on the left-hand side is I'm just left with 5x plus 4. That's equal to 3 outside of x squared plus 2x. Now, that means that, now you notice I'm using a lot of brackets because I hate to see people make errors in expansion. So you need to take care. It doesn't take any longer to do. Just take an extra step. Make sure you put it in brackets, get the signs correct, get the expansions correct. All right. 5x plus 4 is equal to 3x squared plus 6x. Move everything over. We're going to get 0 is equal to, good, 3x squared plus x minus 4. All right, minus 4. Now here we have a quadratic equation. Now we're thinking about this quadratic here. I've drilled into you so much that you need to know how to do quadratics that if this point in time you either should know how to do it or you are working on it because you've come to see me and you're talking, or that you're secretly hiding that you can't do it and you haven't wanted to ask me, and so we're in this awkward kind of tense time, right? But let's not do that. We need to be able to do it, so please let me know. So there's two numbers. We need to factorize this. Two numbers need to multiply to negative 12. Why is it negative 12? 3 times negative 4. The A coefficient and times the C, all right? And the sum has to be positive 1. Fortunately, there are two numbers that do that, minus 3 and 4. So I'm going to break this up into two. 3x squared minus 3x plus 4x minus 4. This is sometimes referred to as product sum method, or some people might insult me and say it's the less sophisticated T-bar method. I don't really care because I know that it works. 3x, x minus 1 plus 4, bracket, x minus 1 is equal to, factorize in pairs, 3x plus 4, x minus 1 is equal to 0. Now we're thinking, okay, solving a quadratic equation. We should all know how to do this. We've done it before. What is it that makes this bracket 0? What is it that makes this bracket 0? Question mark, question mark. Now, easiest way to do it is the following. 3x plus 4 is equal to 0. The idea is that if something's 0, no matter what you multiply it with, it's always the whole thing's going to become 0. 3x is equal to minus 4. X is equal to negative 4 on 3. That's one of my results. The other one is x minus 1 is equal to 0. X equals 1. So if you like, that's my first result. That's my second result. So in this case, my original question, actually there are two x's which satisfy this algebraic fraction equation. All right, exercise 3.2. Send me an email, come and see me in class next time when you have a question about it. Happy algebraic fractioning. All right, see you later.